Okay. Everything looks good. Good morning. I'm sorry for being the excuse for you have to come so early. I had to be the first speaker in the day. Everybody hates him, but please forgive me. It was my call. I'll try to make it as fun as possible to wake you up a bit. I usually do voting by standing up, but again, it's too early, so we'll skip that. This is me. My name is Baruch. J Baruch in every possible social network. And that's because I'm a developer advocate with JFrog. JFrog is a startup company based in Israel and California. We have two products, Artifactory and Bintray. And today we are going to talk about interesting stuff around Bintray, not about Bintray itself. The job description of developer advocate has two main responsibilities. I need to hang out with really cool technology guys and then come here to talk to you about. And this is a challenging job in both places. Well, the agenda is mostly mere Borrower memes. There will be a number of them, and this looks like a multiplex, so it will be a lot of movie references as well. I can count 9. Let's see how many you will find. Look who's get well. Hi, Guillaume. This has been Bintray. I already said this talk is definitely not about the product itself. I will going to do a live night hacking session at 11, and it will be a little bit more about Bintray as Bintray itself. Here I will take a minute to explain you what this product is, for you to understand what were our architectural decisions in order to understand why we have a challenging development environment. So it will take just a minute. Basically, Bintray is software as a service offering. It's a cloud platform that distributes binaries. So basically stores binaries inside. So far, simple. But then it's got complicated because you need to be able to find those binaries, we need search, and in order to give additional value both to the publisher and to the consumer, we have a lot of metadata. A little bit of social stuff, a little bit of proper metadata on the files like licenses, etc., etc. It's complicated because it has two contradictory requirements. First of all, it should be very simple and fast, because it should be a fast storage, but on the other side, we want to give additional value like metadata, etc., etc. So from one side, it should be simple, from another side, it's kind of complicated. Well, most of the Bintray core developers come from a consulting field. And being a consultant is going to places and talk about cool technologies and frameworks that others can use. Which means that we are not scared from a lot of framework and technologies, and when we feel there is a need to add additional one, we just do it. Which means that we might have a lot of them in Bintray, and this is exactly what's happening. So, Bintray uses smart storage. It uses a checksum storage, a little bit like Artifactory, if you're familiar with, or maybe with Git. We hold the files under their checksums and then just display the correct path in the UI, so it looks to you like a file system when essentially it's just a storage of checksums. And this is very efficient. It allows us deduplicate very well, manage it smart enough, move is free, copy is free, etc., etc. But we need to map in some way between the checksums and the actual path that you would like to see in the UI and your REST API, etc., etc. We use CouchDB for that because CouchDB is extremely fast and very, very reliable. It's simple to use, and it's just 2 columns, checksum, and the path on the other side. as I mentioned, very fast, very reliable, but not very friendly in terms of queries and complicated model. And we do need a complicated model for all the metadata around the package, the one you already saw. It's quite a schema. On the other side, Bintray is out for a year now, so those are still early days, and we want to be very agile with our schema. We want to change it on the fly because we are requirement driven, and if we see a lot of requirements to add something new that will change our model, we will just do it. This is not very easy to do with CouchDB because all the indexes need to be recalculated. The same as with the relational database, it's not very easy to do. There is a very nice non-relational database that allows us to do it, and this is MongoDB. Yep, yeah, MongoDB. So when we need to add the metadata, then we just took MongoDB. And of course we need UI framework that you will see a nice, hopefully nice and beautiful UI. We went with Grails because we love Groovy, and Grails is a very good rich internet application frameworks. And next we need caching, so we went to Memcache, and then we didn't like it a lot for Java and Groovy applications. It's not very good fit, so we switched it to EHCache. And I already mentioned the full text search. We started with Sphinx, which looks very fast and efficient, but again not very useful in Java application, so we switched to Elasticsearch. And then we needed a working queues for non-real-time jobs like recalculating indexes and calculating statistics and this kind of stuff. So we need queues. We added another non-relational database that does it very well, Redis. Yeah, that's fourth non-relational database in one system. And we have a very good excuse for each and every of them, except of that we love stuff. We needed a good HTTP server, so we started with Apache, and then we switched to Nginx. And this is a rather complicated picture. To make things more fun, we are very liberal with our approach towards operation systems of the developers. There are developers who use Unix, there are developers who use Macs, and there are some who prefer for various and strange reasons Windows. I, for example, need it for PowerPoint and Office stuff that I do for talking, but others use it for other reasons. Anyhow, this one is fine, this one is fine, and even this one is fine with us. Well, this is challenging, because now what choices do we have as developers of Bintray? We can have central services. We can take like one server and install all the databases on it, and then let the developers connect to it. Hopefully they will not ruin it very much, or maybe we'll be able to separate kind of schemas for each one of them and then let them play with it a bit. Anyhow, this is not very scalable because developers ruin stuff. This is what we do for a living, right? Mostly. So it won't hold. Other option is installing all those services, all those databases on each and every machine. So we need installation routines for each and every of the machine, for each operation system, all of the databases. And again, once I root something, I need to go and reinstall it, uninstall it, drop it, refresh it, or do this kind of stuff for each and every one of them. And then the 10 minutes that I will have, except of it, I probably will write some code. This is also not a very good solution. So we thought of a very natural one, which looks at least very natural to us now, but back of the days, it wasn't an obvious choice. This is what we did. It's not that trivial. No, that was a joke. This is what we did. So we had three actors in our environment, this guy, and this guy, and we will start with Chef. This is Chef. Promised you a lot of movie references. Who knows this one? It's not very popular, but Guillaume probably knows it. It's a French movie. Very good one. Okay. No, it's not that Chef, it's that Chef. Well, screenshot from the official site. Chef is an automation platform that transforms infrastructure to code. You probably know it, right? Who knows Chef, or at least what Chef is? Yeah, good amount of people. This is what I expected, and this is a good thing. So you know, you write code, and then infrastructure builds out of the code that you wrote. And this is a very good start, even if we would take the approach of install everything on each and every machine. This is a step forward. We won't need to install it manually. Now we have some script that we run, and it installs the services we need. This script is actually a unit of configuration, a scenario. For example, that we will see here, and again, this is example from the official site. It's how to install MySQL out of this script or scenario. It's called cookbooks, naturally, because it's Chef. So this is how you install MySQL by writing code. This is Chef example, so it's pure Ruby. There are other alternatives that also use Ruby, most of them, with a little bit of more DSL, a little bit of less DSL. Chef is more or less pure Ruby. So this is what is it. I don't know much Ruby, but I can see the strings. So the strings here, install MySQL service. This is something that even I can understand. This is how it's done. So we could have those codebooks for each and every of our services, for CouchDB, for MongoDB, for Redis, Elasticsearch, etc., and then we can run those on the developer machines. But again, we need to maintain 3 versions of those for each and every operation system, and 2 of them won't be consistent with our production target operation system, which is Linux. So it might be a problem. So this is a step in the right direction, but not enough. Anyhow, someone want to ask why not Puppet? Because I have a slide for it. Why not Puppet? Thank you. There are 3 kinds of questions. There is a good question that I have an answer for. There is and there is a great question, 2 types, which I have a slide for. This was a great question. Really, yeah, you can decide. So we couldn't decide, and we just went with what we had a little bit more expertise in, and this is Chef, but probably Puppet would also work great. More so, Chef has a little bit of complications we will see down the road that probably Puppet won't have. I'm not sure, but this is what I heard. So maybe it was even a better choice, but we didn't. So we stick with Chef for now. Let's look at the other guy. The other guy, this one is Vagrant. So this is a Google search for Vagrant with safe search turned on. Anyhow, this is not something that looks any familiar for us, but actually the Vagrant that we search is this guy. So again, screenshot from the home site. If you're a developer, Vagrant isolate dependencies, etc., and give you a single disposable consistent environment, and this sounds like exact match to what we need. We actually look to for an easy way to get disposable, consistent environment, especially when we have a complicated one. So, Vagrant does 2 things. It boots a virtual box, or any virtual machine, and then it runs provisioners. It comes with different kind of provisioners. One of them is the Chef provisioner, which means that Vagrant can run Chef cookbooks to set up the machine it creates, which is great. And there is something that's called Chef Solo, and this is not to be confused with Chef server, and we will get into it in a minute. So the Chef solo provisional allows you to provision the guest using Chef. So here is exactly what we need. There is an example, so you can see here a number of things. First of all, we select which machine Vagrant should create, and our example is CentOS. This is our target machine in the production, so this is a natural choice. And then we want to use Chef as a provisioner, and this is the path to our cookbooks. This is the local path. Cookbooks are on the developer machine. We're going to talk about it in a minute. And then we just go and provision various sets of cookbooks which are under a single group that's called role. So Bintray common Vagrant server, and then for an interaction, which is the UI, and then for the download, which is the download server for the files. Here we go. This is actually more or less the whole magic. In the development, we have Oracle VirtualBox that has CentOS running on it with Vagrant, and then Chef Solo. So, as I already mentioned, Chef Solo is a flavor of Chef that runs locally and requires the cookbooks to be on the same physical disk as the node itself, as the Chef engine, which means that the cookbooks should be checked out on the machine of the developer in the development mode. And when we mention checkout to the local machine, we actually mention version control. So we use GitHub, but it really doesn't matter how the books got to the machine of the developer, as long as they come from a proper source control. So this is our example. You can see here all the needed cookbooks checked out on my machine. It's CouchDB, Elasticsearch, MongoDB, and Java, naturally, and all the rest. And this is actually something that kind of a mind switch, because now the DevOps that provision our developer machines are coming to our development environment. Not only they use those cookbooks to deploy actual production machines, they use the same cookbooks to set up things on my machine. Which is, of course, great news, because now I can be sure that what I run on my machine is exact same thing that runs in the production environment, which means it gives me the confidence that whatever works on my machine probably will work in production. Nah, it don't. But at least I have the confidence that it will. Probably it won't. I have a dream to have a sticker here. Works on this machine. I'll do it once. So, but yeah, it gets closer to it than doing it by any other means. So actually this is it. This is most of the magic. So Vagrant boots CentOS on VirtualBox. Chef installs all the database and services for as RPMs from the private YAM repository, which happens to be Artifactory in our case, and this is it, right? So now we have all the environment in my box, and I can connect to it and write my code against it, and we will talk a little bit about how to connect to it during the demo. Next step is how do I take this stuff to production? Okay, so I need to be sure that whatever runs in my VirtualBox will run in the production in the exact same way. And for that we need the third guy, and the third guy, as you probably guessed, is Jenkins. The idea is take the same cookbooks and just put them and just run them not on my machine, but on a production server. So we can actually run the same stuff and do the same exactly. Now, this is good. We can take this and put it into the cloud, and this is what we want. We want to use as many cloud services as possible. But we have a problem, and this is the Chef Solo, as we already mentioned. So the Chef Solo runs locally on the machine, but now we don't have a VirtualBox machine. Instead, we have the machine on the cloud. It runs the same CentOS. The provision with we use JCloud and an abstraction above our cloud provider in order to be able to be locked out and switch to another one if this won't fit us anymore. But Chef Solo won't fit anymore. We want to provision in the cloud. So we will use Chef Server instead. Chef Server, the same concept, but now the cookbooks are running not from the same machine, but from the service of Chef itself. It's a cloud service. And another thing that we actually prefer is not to run all the databases by our own. And this is for a very simple reason. We are good enough with them to run them on the development machine, but we believe that there are better professionals than us in those services when it comes to real big scale and production code. So we will use cloud services for that. We can use MongoHQ or other MongoDB providers. MongoDB, that's the one we use, and there are also providers for CloudDB, CouchDB, Cloudant in our example, but again, there are others. And the same for Elasticsearch. Elasticsearch is a service by itself. For any others which are not available as a service, like Redis, for example, we will run them on this machine. But wherever we can offload the babysitting of those very busy and big services and clustering them, make them highly available, I will have time for questions, a lot. Make them highly available, etc., etc., we would actually prefer going to the services that know better. So, just to summarize our setup, we have the good sides, which is very easy setup for the developers. I actually had a new machine and I needed to set up all the environment for this demo. I did it just before, day before leaving to JFocus. It took me half an hour. We will see whether it works or not now in the demo, but at least it looks successful. After a half an hour, I had 4 non-relational databases, bunch of other services up and running, and I can be productive and start writing my code. And this is impressive, at least I think so. Same setup for my development and for production, including the CI. All I need is run the same machine in the CI, the same procedures, and it looks the same. And something that I already mentioned is the provisioning of changes. Now the team lead, the architect, decided that we need to change something in our environment, and that we won't work with one service, but we are going to work with another instead. We change things to Elasticsearch. Other developers are going to get those changes in their machines pre-configured automatically. All they need to do is to update their cookbooks and provision the VirtualBox again. Right, so it will take them 10 minutes, and then all the changes in the infrastructure are done automatically. And this is a not intrusive process. It's not that now the system administrator is going to lock down your computer, log in, make changes, change your files, go to your folders, do the stuff, change the ports, and suddenly your Spotify won't work anymore because they changed some port or something. This is not going to happen. It's all isolated in your virtual box, and you just get a new one which will be configured differently. Very non-intrusive. And something that, as I already mentioned, is very important to us as a developers, we have a total liberty to mess with this environment as we want. We can screw it completely and then tear it down, run it up again, and we have brand new working clean environment. This is again very, very productive. I don't need to think, okay, now I'm going to do it, how am I going to revert my changes, will it affect me, will it take me time to get to the previous state, and this kind of stuff. Really don't care. I can do whatever I like with my machine, kill it, boot it up again, and it's brand new. So we are very, very pleased with this solution, and we really recommend to use it for anybody else. There are some downsides, and without them this presentation wouldn't be so fun. Just a couple of them. Chef Solo is not exactly Chef Server. There are differences in provisioning, there are slight differences even in some of the cookbooks themselves. So this is a little bit of a challenge, and probably if we would have changed Puppet, we wouldn't have that problem. I'm not sure, but this was my impression. But that's okay, we managed with that. The other downside is much more of a communication problem, and when I used to install my Oracle Express on my developer machine in order to write some JDBC code, I knew exactly how to install Oracle Express. It's not that this is some knowledge that is useful the day after, but at least I knew what's going on my machine. Now it's a little bit of the black magic for the developers, because I run some command, I open this guide of how to set up your environment. It has like 5 bullets. I do it one by one. It takes time, provisioning, boom. I boot up my IDE, and it looks like all the services are up. So I not really know what's going on, but this is a matter of communication and curiosity and you know, knowledge sharing. So it's not really a technical problem. They won't force me to know this thing, but it will be nice if I actually ask for myself. I mentioned the good, I mentioned the bad, now I should mention the ugly. Well, I didn't find anything ugly in particular. It used to be the chef homepage that was really ugly, but it's not anymore, so I can't even put it there. So I just told you movie references. Well, the slides are short, and now let's see what I will be able to pull up with the demo. I had my demo all set up and running, and then this is Windows, so the machine crashed. Now I boot it up 5 minutes before the talk, and we will see. We will see what will happen. Okay. Frankly, I wasn't so unsure in my demo for a long time, and I do this stuff like a lot. Okay, this doesn't look good, but we'll start with something else. Vagrant up. I let it work. This will boot my... Where is my virtual machine? Here is it. So this is a virtual machine, and there is a tiny screen that shows the preview of CentOS actually booting. And this is Vagrant's job. In the background, in the headless mode, it communicates with the VirtualBox and boots up my machine. It actually looks not that bad, so maybe we will be able to pull something off eventually. In the meanwhile, I will show you some code. So, this is a Vagrant file. You already saw a screenshot. And those are the instructions of how to boot up the machine. So it has here Vagrant configure, and then what I mentioned earlier, boot up CentOS 6 and take the cookbooks from the checkout directory, which happens to be a directory in my machine, and then install all those. Install the common part, which probably means Java. Install the interaction part, which means MongoDB and Elasticsearch, etc. And install the download part, which means CouchDB and Nginx and this kind of stuff. So there is an interesting part here, and this is the assigning the IP to the VirtualBox. Now, I need that. Actually, I will show you a couple of more slides to explain it. Okay, so the picture that you already saw, this is our setup. Now, as a developer, I write my code here. I write Grails, I write groovy Grails application. So if I put all that in all my VirtualBox, there are no communication issues between Grails and the rest of the services, right? So when I try to connect to my MongoDB, this is local. Just need to go to the local machine. But this runs in the VirtualBox, and my IDE is outside of the VirtualBox. So actually now my code is remote to the container it should run in, which is Grails. So this is one solution, but the problem is it's not very productive. My debugging is remote, and this is not very fun. So what we did, we took Grails out of the VirtualBox. Grails is installed locally because it's just a bunch of files, and you boot it up from your machine. So in my setup development environment, I have one bullet which is, okay, you got all the magic from VirtualBox, but there is something you need to install manually, and this is Grails. So Grails is installed on each and every machine separately, and then it needs to communicate in some way with all the services which are inside VirtualBox. So there are two solutions for that. We can remap all the ports for all those services from the VirtualBox to the host machine, and then it will just be local as it was inside the VirtualBox. And the downside of this approach is all those ports will be taken on your host machine. The other approach is give an IP, a known IP, to the VirtualBox, and then connect to all those services by that IP. So we had the first solution. Now we are on the second one, and this is exactly what the private network IP does. We assign a known IP, and then we can connect all those services. Let's see what's up with our... Okay, it looks like Vagrant is up and running. Let's see what our VirtualBox says. Yep, it looks running, and we can see in the preview that it actually has a terminal waiting for us to log in. Let's do it. Vagrant SSH. And we are inside our VirtualBox. Now the question is, was it configured? Do I have everything I need in it? So I can check if, let's say, Mongo runs. And here is the Mongo process, MongoD. This is the MongoDB server, and it runs, looks good. Let's do the same from Couch. This is CouchDB server, and what else? Elasticsearch. And here's the Elasticsearch up and running as well. So, Vagrant up, I don't know, 50 seconds, 20 seconds later, I have all my services configured and I can connect to them. Now, let's try to boot something up because I really want to show you something up and running. So I will try to run the download server. This is a prerequisite for running the interaction when you will be able to actually look at something. This looks good, right? Yeah, that wasn't an exception, it only looks like that. Really, this is very confusing. I don't remember which, I think it's Spring. It lists some list of files, some list of classes that it found with a fully qualified name, and you're like, well, exception. Oh, no, that's okay, that's a class list. And it was a class list. Okay, now let's try to run Grails. Did I click on it? No, I didn't. Okay, now I did. It will take a minute. In the meanwhile, let's continue and see what I have to show you. Okay, now this is an Elasticsearch cookbook, Elasticsearch recipe that runs Elasticsearch. As I already mentioned, this is Ruby, but again we can see good strings that will help us understand what's happening. So here, service Elasticsearch. Just take a template that creates the service, put it in the init D, and then it will work. You can see here we verify that it has the needed binaries and start the server, give the correct permissions, etc., etc. This is another recipe which actually runs a list of various recipes inside, and this one we're going to run the Mongo, Redis, Java, Elasticsearch setups for us. Yeah, this one I already showed. Okay, this is the provisioning log, and here you can see the provisioning log is the output of Vagrant when I actually ask to run chef. I didn't do that now because I expect it to be pre-configured, but if there were some changes and I want to now provision the box again, get those changes, this is the output. So I can see here that I had installing MongoDB and probably install JDK and install Elasticsearch. What else? And install Couch, all the services. So all this done during the provisioning of my new VirtualBox. This is kind of a little bit of time consuming. It takes, I don't know, maybe 10 minutes, maybe less, 7 minutes, something like that. Let's see how our Grails application, whoa, it looks up. Okay, so let's see what's going on. Okay, so this is live Bintray.com. This is, I should see something similar in my local machine. Yep, and this is my local Bintray that you just now saw starting from scratch. Again, as I said, very, very simple and powerful setup. And now, thank you very much. We have 10 minutes for questions, and please, go ahead. I need to stop it, this is very distracting. Yeah. Sure.
What about Vagrant and bare metal provisioning?
Vagrant on bare metal? You mean on the machines of the developers?
No, I mean, like, for example, you would use Vagrant to set up your recipes and define what you want to do.
Yes.
Connect, for example, to an OpenStack cluster, and then running Ironic, and then basically do the bare metal provisioning there.
Oh, I see. But okay, so for that the question is where this code is going to run. So I need a central server for that. That will install different, that will have, each and every developer will have OpenStack machine. So the idea here, it should be as toyish as possible, because I need to run it on a MacBook Air, probably, locally, because I want a fast local link and everything. So.
I had another question about a setup where you said you depend on a lot of cloud services.
Yes.
How do you handle the latency? Because the result of being in the clouds is that your different databases will basically have different time for responses.
Yes, those databases are not participating in one transaction. So as I mentioned, the two main pieces, the CouchDB and the MongoDB, are actually used in two separate processes. So I run two processes now to show you. One was the download server, which is only a very simple application that only connects to CouchDB. And the other is interaction which uses MongoDB a lot and a little bit of CouchDB, but mostly MongoDB. So they are kind of isolated. I don't need to synchronize between them almost at all. Now, regarding the latency is a valid question for even if we use our own machine in the cloud, right? So we do what we can. We have a very fast CDN for the downloads, because this is where the latency actually important, and we use locality redirects for our web application. So probably when we are in Sweden, we are going to see the Bintray website from Ireland, and where we are in the States from East Coast or West Coast accordingly. And for the downloads, we'll have it probably for the server next door because of the CDN. So we do what we can. Yes?
So in Jenkins, do you run the provisioning every time you do an automated build? For instance, if you want to do integration tests, or because that would be very slow, right?
No, we run provisioning where there are changes. Because the Gradle application is not provisioned by Chef. Where the changes are, where we write code.
No, I mean, on the Jenkins machine, does the Vagrant stay up all the time, or do you restart every time you do build?
No, we actually restart it every time. We reset to start it from scratch, and the provisioning takes, as I mentioned, on my machine, which is not the server that we run our test on, like 7 minutes. So there, all the development of Bintray, if I remember right, and drawer here are VPRNT will correct me if I'm wrong, about 10 minutes. The build of Bintray on Jenkins? 15 minutes.
So every time a developer checks in, it builds for 15 minutes? Is that what you're saying?
Yeah, on different.
It doesn't start happening.
We have the Vagrant run all the time.
Without changes.
Yeah, only the changes. So it's good to have you here. Yes.
So because the provisioning is so lightweight, it takes only half an hour, 15 minutes. So if you have a configuration change for the setup, for changing some module or something,
yeah.
do you always provision from scratch, or do you support incremental provisioning?
For the developer machines?
Not for the production and other QA environments.
No, it's only the changes.
Only the changes.
Yes.
So it supports like
Yeah.
deleting or removing and adding modules.
Yes, yes.
What about the data? When you provision a developer machine, where do you get the data so you have meaningful tests?
So we have an export of, for example, MongoDB data that is also provisioned through the same cookbook. So once it goes like take the MongoDB YAM and set up the service and start the service and then import the reference data.
So you use kind of like the production data to be sure?
It's a subset of staging data, actually, yeah. Subset of staging data. Okay, is there something good outside, like food or drinks, that you really don't want to talk with me anymore and go eat? Because that's fine. I just need to know because I need to run first then. Thank you. Thank you very much.